All right, so good morning. Welcome to week 3 of your online learning, Geometry Edition. Okay, so we're going to start with 10-3 of your textbook, area of regular polygons. All right, but before we can actually find the area of regular polygons, we need to see what are the parts of a regular polygon, or better yet, what is a regular polygon? Okay, so when we're talking about regular polygons, we are talking about polygons that have equal angles and equal sides. So down here, with this, this polygon, we have a pentagon, right? It has 5 sides. So all of this, all the sides that I'm highlighting, they would be equal to each other. And the angles, they'd also be equal to each other. All right, that's what makes it a regular polygon. Now, since we can draw a circle around regular polygons, we're going to find that it has certain parts. So it has a center and has something called the apotheum, right? The apotheum is the line that is right between 2 radii, and it is it's bisecting the central angle in half. Now, what do I mean by radii, and central angles? So by radius, I'm talking about all these dotted lines that are meeting at the center. All of this would be radii. So one would just be a radius, many would be radii, right? That's the plural form. So, and when we're talking about a central angle, we're talking about the angle formed when 2 radii meet. So it would be would be right over here. That would be our central angle. All right, so just let's label that. This is our central angle. Okay. And this would be our radius. Okay. Now, over here, this apotheum, this line is bisecting or cutting the central angle in half, right? And so this half would be equal to this half because they come from the same angle. And another thing about the apotheum is that it's going to be perpendicular to the sides of the polygon. Perpendicular, they're forming these right angles right over here. Okay? So now that we went over what are the parts of the polygon, we can actually move forward to how do we find the angle measure. So let me just clear this. Let's move on to the next slide. So if we're trying to find the angle measure of polygons, we need to divide 360 degrees by 360 degrees by the number of sides to find the central angle. And then if we have to find multiple angles, we have to use the apotheum and the characteristics of a right triangle. But mainly your step to finding the angle measure is going to be dividing 360 by the number of sides. Now we're dividing 360 because all your polygons, they can, a circle can be drawn over them. And if, let's say, for example, someone is doing a 360 on I guess, a skateboard or a surfboard, they'd be going around the circle. So 360, that means that that's the number of the number of degrees that a circle has. Okay, so let's write that down right over here. 360 degrees, total number of degrees of a circle. Okay, so that's why we're dividing 360 by the number of sides. Right. So let's see an example of this. So let's look right over here. So let's say they want us to find the angle measure of a polygon with 12 sides. So the way we're going to do that is we're going to divide 360 by the number of sides. Let me just call the number of sides the variable s. So they gave me the number of sides, it's 12, so 360 divided by 12, that would be 30. So the angle measure of the polygon here is 30 degrees. Okay, so that's one example. We're going to jump down to another example, a polygon with 24 sides. So it's the same formula as before, 360 divided by the number of sides. And we're going to do 360 divided by 24. So if we put this in the calculator, 360 divided by 24, we would get 15. The angles of this polygon would be 15 degrees. All right, and it's going to be that same degrees of the whole figure. Now, let's look at a more complicated example. Let's look over here. So in the diagram, ABCDE is a regular pentagon inscribed by this circle. Find each angle measure. Okay, so here we need to find the angle measure of all these different angles. And we have this pentagon right over here. That's a 5-side figure. And they gave us some information. We have 2 radiuses, radii, and then we have the apothium. I know this is the apothium because it's starting from the center going straight down and making those, and it's perpendicular, so it's making those right angles. So let me just make this a little bit bigger and maybe change the layout. Okay. Just so you can see it better. Okay, so right over here, if we're trying to find the measure of AFB, well, first I need to find out what do they mean by the measure of AFB. So you're going to start with A, F, B. Okay, cool. So by AFB, they're talking about this right over here. And if we notice, that's an angle formed when 2 radii meet. So that's our central angle. Okay. So to find this angle, we have to do the same thing as before. We have to divide 360 by the number of sides. So over here, a pentagon has 5 sides, so 360 divided by 5, that would give me 72. So 72 degrees would be my central angle right over here. Now they want us to find the measure of angle AFG. So where would AFG be? So let's start again. AFG. Okay, they're talking about this angle right over here. an angle formed by a radius and the apothium, all right? And if we remember with the apothium, so here we have the apothium, this bisects the central angle. So this line is cutting the whole angle in half. So to find out what our AFG is going to be, we need to do 72 divided by 2 because we're cutting it in half. So 72 divided by 2 is 36. What? Why did I do that? So this angle would be 36 degrees. Okay, we're good. Now we're going to go look at angle GAF. Okay, so I need to first mark down where GAF is. So let's use red. So we have GAF. All right, GAF. So we're looking for this angle right over here. That angle. Now, if we look at this over here, we see that we're forming a right triangle. So if I was going to redraw this outside, it'll look similar to this. So G would be over here, F would be above, and I'm just like copying with what I see over here. So I know G is at the corner with the right angle, F is above that, and A is across from G, right? And we already found some of the angles over here. So let's see, we have AFG, this angle, we just found it, it was 36. And this, over here, this means it's a 9-degree angle. So if I want to find the angle GAF, this angle right over here, I'm going to have to use a property of triangles, right? So that means the property I'm going to actually use is that the total number of degrees in the triangle is 180. So let's write that over here. Total number of degrees of a triangle, and this goes for any type of triangle. A right triangle, scalene, isosceles, they're all going to have 180 degrees. Okay? So I'm going to use this fact to help me find what this angle is. So first I'm going to add these two angles. I'm going to add 90 plus 36. And that should give me 126. Let me just check that. 90 plus 36, yes. And now from here, this 126, I'm going to subtract this from the whole, from the total number of degrees. So I'm going to do 180 minus 126. Why am I doing this? Is because I already have these two. Now I just need to know what's left. So I'm going to do that. And I'm going 180 minus 126. And I'm going to find that this angle is going to be 54 degrees. Okay. So here, I just found all of my angles. Now, let's say, for example, we have a question that's asking us to find sorry. So this question over here is asking us to find this angle. And the way we call that angle is, oops, I erased everything. So yeah, let me just redraw it again. Huh. They want me to find this angle right over here. And we're going to call this angle, measure of angle, BFD. So if they want us to find this whole big angle like this, right? You see how this part is forming a triangle? Oops, this part over here without the apothium. Okay, so we're going to use, what we're going to do is that we're going to make triangles going to our endpoint right over here. So that's one triangle, two triangles, three triangles. So this whole angle is made of three angles, three triangles. And we've already found out what this angle is. From our notes from before, that angle was 72. So this was 72. Now because this was 72 and everything is part, and this is a regular polygon and it's part of a circle, this will also be 72. And this will also be 72. So to find this whole big angle, I'm just going to add 72 3 times, or just do 72 degrees times 3. This would give you, I think it's 216? Hold on. Yeah, this would give you 216. So that's the measure of that. All right. Okay, so we're going to stop here for today. Tomorrow we're going to actually look at finding the area and perimeter.